Hello biologists, we're going to do a lab on homeostasis today. You can see we have a simulation here with a person who can run on the treadmill or walk. Let's turn on the simulation and watch this person. You notice we have two sensors here, air temperature and body temperature. Homeostasis means trying to keep the same level. Your body tries to keep the same body temperature by sweating. So if we turn on automatic sweating here, we can see that your body can better maintain homeostasis or keep the same body temperature. So we see we can turn on sweating, or if we turn off automatic sweating, we can control the sweating here. We also have some other variables. Variables are what you change in an experiment. Remember, we only want to change one variable at a time. So we want to change either standing or jogging or running or the amount of sweat, or we can change what the person is wearing here. We can put a sweatshirt on them or a hat. The system will automatically tell us when to drink water or eat food. Here's an energy bar you can see, and we'll be working with the system here. The simulation will tell us to drink water or eat food in this bar up here. So now that we've explored the simulation a little bit, we're going to ask ourselves some questions. What are some things that you do to stay cool on a hot day? What can you do to warm up on a cold day? Think about what happens when we hit, say, run here. What happens to body temperature? Look at the body temperature here. This person isn't sweating automatically, but you can see what happens. What things does your body do to automatically cool down or warm up? Think about those things. You can think about perhaps some of these things in your gym bag here, or some of the tools you have here that you might use to warm up or cool down. So I'm going to reset the simulation, and we're just going to explore what happens. Let's go back to a walk here. Oh, we're already up to a pretty dangerous body temperature. What can we do to bring down this dangerous body temperature? And why would that be a good idea? I turned on automatic sweating here. So now the body's got a better, just like your body has a built-in mechanism to cool down here. Your body can maintain homeostasis by sweating if you get too hot. Oh, this person is thirsty, so we're going to have to give her a drink of water. If you're sweating and sweating, what's your body going to have to do to keep sweating? And if you're burning energy because you're running, what is your body going to have to do to maintain homeostasis in terms of chemical energy? What do you do to maintain chemical energy? Oh, she's getting cold. What are we going to have to do here? What should we do to warm her up? Should we get her to run? See if that helps? The air temperature is 0 degrees Celsius versus 32. That's pretty chilly. Maybe we should do something else here. If we put clothing on, does that help? Body temperature is pretty good now. All systems are normal. Oh, she's hungry. We better feed her. If she's putting out a lot of energy, her system to maintain homeostasis has to take in energy. Oh. And if she's sweating, the air temperature has gone up. we better take off our sweatshirt and her hat. An air temperature of 40 degrees Celsius is 104 degrees Fahrenheit. That's a pretty hot day. You don't want to be wearing a hoodie and a hat when you're out. The air temperature changed, so we have to make a change to maintain homeostasis. You can look at the body temperature here. It's 40 degrees C. Your body temperature is 104. That's not a good idea. So let's take off her sweatshirt and see how she does. Oh, her body temperature is still really high. Let's slow to a walk and see if that helps. That's a little bit better. All right, she's dehydrated because she's sweating so much. So we have to refill that system, maintain some homeostasis. She's burning a lot of energy, so we have to put energy back into the system as well so she can maintain homeostasis. Oops. I just killed our person here. Let's start over. Let's see how the amount of sweat changes. I have automatic sweat on here, and you can see the amount of sweat right here. Let's see how the amount of sweat changes as the air temperature changes. I'm just gonna hit run here, or hit play, and she's running. I have the run box checked here. And it's 3 liters per hour when the temperature is 20 degrees Celsius. As she's chugging along here, the air temperature might change. Oh, we've got to stop. To maintain homeostasis, you've got to drink water to balance the amount of water in your system. And you also have to balance the amount of chemical energy that your body is. You have to take in chemical energy because running burns chemical energy. You use up chemical energy. Let's keep going here and see if that amount of sweat changes as the air temperature changes. It's 20 degrees Celsius, it's 68, it's a nice fall day. Now, oh, wait, let's wait a second here. Now she needs to drink water and eat food again. That's why we have to keep eating and drinking, because we keep sweating and we keep using up our chemical energy, and so we have to keep taking it in as humans. So as the air temperature changes, watch the amount of sweat she's putting out. She's out on a nice fall day. She's drinking some water. It's pretty warm. She's got to eat some food. Oh, look, the air temperature went down to 32. A storm must have come in today. And now look at the amount of sweat. It's 0.5 liters per hour. So it went from 3 liters per hour to 0.5. That's pretty significant. She's sweating a lot less because the temperature is much colder. So let's take a moment to look at the data that we've collected so far. Don't worry, you don't need to put data on a data sheet. I'm doing it for you. Let's look at the time. So the air temperature at 1 hour was 20 degrees Celsius. The body temperature was 37, and the sweat was 3 liters an hour. When the air temperature here went down to 0, body temperature stayed pretty much the same, but the sweat dropped a lot. Now at 3 hours, the air temperature is probably going to change again, and we'll look at body temperature and sweat. What do you think is going to happen if the temperature goes way up? Like she's out running on a very hot day in the summer. Will the sweat go up? Will it be higher than 3 liters per hour, or will it go down? Even below 0.5 liters per hour. Let's see what happens. So our person needs to eat or drink again, because in order to maintain the same amount of water in your body, because you're sweating, you need to take in water. And in order to maintain your chemical energy, you need to eat. Your body can also burn fat, but that's harder to do. So we'll just give her an energy bar. So she's running along. The air temperature is still pretty cold, but now it's really starting to warm up. It's 40 degrees Celsius, which is 104 degrees Fahrenheit. What's going to happen to the sweat here? What did you predict, and what has happened? Let's go put it in our data table and see if we can make. So while she was running, the temperature went way up. It was 40 degrees C, which is 104 degrees Fahrenheit. That's a pretty warm day. Her body temperature was still around 37, but she was sweating 5 liters an hour to maintain homeostasis to try to stay cool. And you could see at the end there she got really hot. We're going to have to give her some more water and give her some more food and maybe slow her down to a walk so she can stay cool enough. If you're out running at full your best pace on a 104-degree day, you're probably going to overheat unless you're very heat acclimated and you've done a lot of training at that temperature. So we better give her a drink of water. She's really hot right now. It's 104 degrees. Her body temperature is 102 degrees, 102.6 degrees Fahrenheit. That's basically running a very high fever. She needs to cool down. So when we turn the simulation back on, we probably better slow her down to a walk or even just let her stand for a while until her body temperature comes down to a more reasonable level. Here, she's at 99. She's probably good right now, and the air temperature has cooled down, so we're good. So now we're going to challenge ourselves. We're going to turn off automatic sweating, and we're going to have to control the sweating. We're basically going to have to do what your body does automatically by varying the amount of sweat, giving the person food and water, putting on a jacket or a hat, and altering our level of activity to keep this person warm if the air gets colder or cool if the air gets warmer. So let's start this challenge and see if we can do it. Oops, I forgot to reset here. All right, let's put her at a walk and just have her walk and see what happens. It's a nice fall day. It's 68. Her body temperature is just going up a little bit. It's 37, 38. Up, we better do some sweating here or she's going to get too hot. Her body temperature is coming down a little bit. It's 37.7. Maybe we better sweat a little bit more here. Okay, she's pretty good. Oh, now she's a little cool. We better warm her up a little bit. Stop sweating quite so much. So we turned down the sweat because she's a little bit hot. Oh, now it's getting really cold out. She's probably, oh, look at her body temperature. It's 34. I'm going to pause and get a sweatshirt and a hat on her so she's nice and warm. Now the temperature is 32 degrees Fahrenheit. That's pretty chilly. That'll freeze water. That's 0.0 Celsius. If you leave some water out overnight and it's that chilly, it's going to freeze. You're going to get some ice on the top of a bucket. Or there might be frost on your car or in your garden at this temperature. Oh, she's pretty cold right now. Oops. We better turn down the sweat a little bit. Maybe get her to run so her body temperature goes back up. Oh, wait. It's going up, but in order to keep putting energy out there to run, she needs some food. She's sweating a little bit. She needs some water. All right, we'll get her back up here. Her temperature is going back up. Air's pretty cold, but she's running now. So she's burning more energy. So the byproduct of burning chemical energy in your body, using it up, is heat. So you convert some of that energy to heat. Uh-oh, the air temperature just went to 40 degrees C. So now we probably need to turn up the sweat quite a bit because it's 104 degrees outside. We need to get her to take off her jacket because if it's 104 degrees Fahrenheit or 40 Celsius, that's a really hot day. So we want to help her thermoregulate, which means regulate your temperature just like a thermostat regulates a temperature. We're going to thermoregulate for her by taking off her jacket and getting her to sweat more. She's at 39. That's pretty hot. Maybe we better slow her down to a walk. And we also Want her to drink some water because she's sweating a lot now. She's losing a lot of water, and we probably better get her to eat a little bit too. All right, let's get her back in the game here. Her body temperature is still really high. We better turn sweat up. That's helping a little bit. It's still really high though. Maybe we should just have her up. We're good now. Okay. So we turned up the sweating. We took off her jacket. We slowed her down a little bit. Now we've got to give her some more water. Oh, she's getting cold again. We better stop sweating quite so much. We also probably need to put on a jacket or get her to move a little bit more because she's pretty cold. So let's turn down the sweat and maybe get her back up to a run so she warms up a little bit. Oh, body temperature is low again. The air temperature went down again. So energy is very important. If you're walking or moving or even just standing outside, you burn a lot in the cold, you burn a lot of energy. So it's important to eat. Not so much at 32 degrees Fahrenheit, but if you're out at negative 20, you need to eat quite a bit to stay warm because your body's burning a lot of energy. Okay, her body temperature is pretty low now, but we put her on a sweatshirt. She's probably going to be okay now. Let's see if it works. Maybe we should turn down the sweat a little bit. We all know that if you're outside and you're cold, you need to move. That's kind of a solution to, you know, if you're standing around at the bus stop, if you went to brick and mortar school at some point and you're standing around waiting in the cold, you know, to jump up and down or stamp your feet or clap your hands to keep moving and to stay warm because that gets your body to burn energy. And the byproduct of movement in our bodies is heat. All right. The temperature went back up. Her body temperature is way hot, so we know that we should take off her jacket and her hat, maybe drink some water. And that will probably solve our problem. Turn our sweat up here a little bit. All right, we're good. So we've managed to keep her alive for 5 hours and 39 minutes. That's a pretty long run. She's gone 46 kilometers, which is almost 30 miles. That's a pretty good distance. This is what athletes have to do, and this is what you do if you're out working all day. You need to balance your body temperature by either taking on and off clothing, drinking some water, which also can help your temperature. It regulates, it fills back up the tank where your sweat comes out of. Your body takes water out of your blood to sweat, and you have to put that water back. Otherwise, you get dehydrated, which means your body is running out of water. You also know that you need to eat if you're out because you're burning energy, you're using up energy in your body, and you need to put that chemical energy back by eating. That helps your body maintain homeostasis. And you also know you can regulate your amount of movement to either stay warm or cool down. So you've seen how we've maintained homeostasis in this runner. Now let's do some thinking about, draw some conclusions. So you've seen this runner warm up and cool down. You've watched her body temperature go up and down. You also try to maintain homeostasis in your house, especially in the winter. Your thermostat runs to try to keep your house temperature at the same level. You don't want the temperature in your house going from almost freezing to like 80 degrees Fahrenheit. that would be really annoying in the winter. So you probably have a thermostat, which maintains the temperature in your house by turning off and on your the furnace or the boiler, if you have radiator heat, um, to maintain a constant temperature in your house. So how is the thermostat in your house like all the mechanisms that maintain homeostasis in your body? So think about that question, and thanks for watching. This is Dr. B signing out.